Welcome to part 2 of finding distance in a coordinate plane. When I left you, we were finding reflected points across specific axes. 5.53, the reflected point would be -3, 5 across the y-axis, and it would be 3, -5 across the x-axis. Once again, notice if it's reflected across the y-axis, the y-coordinate is the same, the x-coordinate is the opposite. If it's reflected across the x-axis, the x-coordinate is the same and the y-coordinate is the opposite. Similarly, -2, 6 reflected across the y-axis would be 2, 6. Reflected across the x-axis, it would be -2, -6. -3, 8 would be -3, 8. And 3, -3, -8. Just to do a quick review, if a point is reflected across the x-axis, it will have the same x-coordinate and an opposite y-coordinate. If it's reflected across the y-axis, the y-coordinate will be the same and the x-coordinate will be the opposite. The next thing we're going to learn is using absolute value to find distance between 2 points that are vertical or horizontal from each other. So if I have a point at -4, +4, and I have another point that is at 2, -4. I know that these 2 points are in line with each other, horizontal, exactly horizontal from each other, because they have the same y-coordinate. The y-coordinates are both 4. In order to find the distance between these 2 points, I can use the other 2 points and absolute value. So I'm now going to take -4 and +2 and find the absolute value of both of them. And then whatever the answer is, I'm going to add them together. I'm going to add them because they are in different quadrants. This is quadrant 1 and this is quadrant 2. I know they're in different quadrants because this is +2 and this is -4. If they're in different quadrants, I need to add the 2 absolute values. So the absolute value of 4, absolute value is absolutely positive, so it's always positive because it's distance. The absolute value of 4 is 4. The absolute value of -4 is 4, and the absolute value of +2 is 2. Distance is always positive. You can't have a negative distance. And my final answer is 6. So I know that these 2 points are 6 units or 6 grid boxes apart from each other. Now let's count it. I like to call it the leapfrog method. If I would leap from starting at 0.24, and I would want to 1, 2, 3, 4, 5, 6 units apart. Using absolute value to find the distance between 2 points is a great way to find the distance without actually graphing the points, and then I call the little leapfrog method of jumping from one point to another and counting. And there's a lot of mistakes that can happen when that occurs. Let's try another example of using absolute value to find distance between 2 points. Given a random point, at -3, -2. If my point is at -3, -2, and I have another point at this location. Notice it is exactly to the right of the other point. And this point is at 6, -2. I know that these points are in line with each other because they have the same y-coordinate. That means that they are horizontal from each other. And the 2 points, if I would connect the dots, connect the 2 points. That point would be parallel to the x-axis and perpendicular to the y-axis. I'm going to take the other 2 points. I'm going to take the one that has the larger digit. So I'm going to take 6 first, and I'm going to find the absolute value of 6, and then I'm going to find the absolute value of -3. Because they have 2 different signs, this is +6 and this is -2, that tells me that they're in 2 different quadrants. If they are in different quadrants, that means I need to add the absolute values. So the absolute value of 6, absolute value is absolutely positive, is 6. The absolute value of -3 is 3. Absolute value is absolutely positive. I'm going to add those 2 absolute values. My answer is 9 units. Let's check it. The reason why we add them is because if I'm going to start at this point and get to the y-axis, I would use the leapfrog method if I had graphed them 1, 2, 3, 4, 5, 6 units from the y-axis. And this point is 1, 2, 3 units from the y-axis. Distance is always positive. It doesn't matter what direction. And the total of 9 units altogether, 6 plus 3. That's how many units away from each other those 2 points are. They're 9 units away. If I were to graph 2 points, and these 2 points were, one was way up there, one was way down there, and I know that they're going to be exactly in line with each other. If I were to connect the dots, it would be a vertical line. This point is at 3, 4. This point is at 3, -6. Notice they have the same x-coordinate. That tells me that they're going to be in line with each other. One's above the other. They are also in different quadrants. -6, 4. If I took the absolute value of the 2 of them, because they have different signs, -6, +4, I would add them. The absolute value of 6 is absolutely positive. The absolute value of 4, also absolutely positive. They are 10 units apart. I'm going to change this one a little bit, and I'm going to say, what's the distance between this point and the red point? Erasing this one and erasing this. I now have another example problem. I want to find the distance between the red point. The red point is at 3, -2. And the blue point is at 3, -6. Remember, same x coordinate. So I now need to take the 2 y coordinates. I'm going to use the bigger digit first, and -6 is my y coordinate. -2 is my y coordinate on my other point. I'm going to take the absolute value of the 2 of them. Notice the absolute value. I didn't put the operation in the middle yet because I have 2 signs that are the same, negative, for the y coordinate. That tells me that they're both going to be in quadrant 4. Because they're both in the same quadrant, I need to subtract the absolute values this time. Absolute value of 6 is 6. The absolute value of 2 is 2. And if I subtract the 2 absolute values, those 2 points should be 4 units apart. Let's check it with my leapfrog method. 1, 2, 3, 4 units apart. Let's do one more to practice. I have 2 points. I have plotted at -6, 5 and -1, 5. I know that they are going to be directly across from each other because they have the same y coordinate. Now we're going to take the x coordinate, -6 and -1. I'm going to find the absolute value of the 2 of those. Now I have to decide, do I want to add or subtract? I'm going to subtract the absolute values because they have the same sign. Absolute value of -6 is 6. Absolute value of -1 is 1. I'm going to subtract the two absolute values, and my answer should be 5 units. Since I have them graphed, I'm going to check myself just to make sure I'm 5 units apart. 1, 2, 3, 4, 5. And those 2 points are 5 units apart. Just to summarize, when I have the same x coordinate or the same y coordinate, I know that those 2 points would be in line with each other, and I can use absolute value to find the distance between the 2 points. If the 2 points have the same sign, you're going to subtract the absolute values to find distance between 2 points. If they have different signs, you're going to add the absolute values because they would be in different quadrants. You need to add the absolute value of the coordinate that is different. Because 5 was the same, I needed to take -1 and -6. I needed to subtract -1, the absolute value of -1, from the absolute value of -6 to get 5 units. Thank you for finding distance in a coordinate plane with me today. Now let's practice. I have a word problem. Tom's house is located at -8, -14. The school is located at -10, -14. How many units apart are Tom's house and the school? I do not have to plot these points in order to figure out the distance between these 2 points. The reason is I know that they're going to be in line with each other. I know that because they have the same y coordinate. Same y coordinate means they're going to be in line with each other. So I'm going to take the other 2 coordinates, the x coordinates, and I'm going to start with the larger digit, -10, and then -8. And I know I can use absolute value to figure out the distance between these 2 points. And I know that I can subtract them because they are in the same quadrant. They are both going to be in quadrant 3. So when they're in the same quadrant, and I know they're in the same quadrant because they both have the same negative sign. Because they're in the same quadrant, I'm going to subtract the absolute values. Order of operations tells me do absolute value first, -10. The absolute value of -10 is +10. The absolute value of -8 is 8. If I subtract the 2, I know that these 2 locations are 2 units apart from each other. Now we have a 2-part word problem. Sammy walked to the gym located at 12:18. Then he walked to the library located at 12:-5. How many units did Sammy walk? That's the first part of the problem. And the second part of the problem says, if each unit is equal to 3 miles, how many miles did he walk? So we're first going to have to figure out how many units he walked. We know that these 2 points are in line with each other. We know that because we have 12 and 12 as the x coordinate. So I'm going to start with the y coordinate. I'm going to start with 18, absolute value of 18, and -5. I know that they're in different quadrants because one is positive, +18, and -5. They're in different quadrants. So because they're in different quadrants, I'm going to add the absolute values to find how many units Sammy walked. The absolute value of +18 is 18. The absolute value of -5 is 5. If I add them, we could use a calculator, we could count on our fingers, or hopefully we just know that 18 plus 5 is 23 units. That's how many units he walked. Now, if each of the units is equal to 3 miles, how many miles did he walk? There is more than one way to solve this problem. If each unit is equal to 3 miles and he walked 23 units, some of you may know that it's very simple. There is one operation you could do. We're going to actually use something we learned in one of the modules previously, and we're going to use proportions. So I'm going to start with miles to units, and I'm going to make this a unit rate problem. If miles is on top, miles is going to stay on top. If units is on the bottom, units is going to stay on the bottom. So 3 miles to 1 unit.